Hi everyone. So this is Manoj. Today I'm going to explain the topic all pair shortest paths, that is Floyd's algorithm. So the main objective of this all pair shortest path is to find the shortest path between each pair or every pair of vertices or nodes in a given graph. The given graph should be directed as well as weighted graph. So for example, here it is the given graph, right? So here I'm having the vertices 1, 2, 3. So that 3 vertices, and these are mentioned as edges. So each and every edge from one vertex to another vertex, there will be a direction as well as some weight. Here the weight is going to be considered as the distance between the vertex 1 to another vertex, right? So for example, from the vertex 1 to the vertex 2, I'm having the distance as 4. Alright, so here in this all pair shortest path, I'm going to identify the minimum distance from each and every pair of vertices. For example, so here I'm having the distance from vertex 1 to 3. It is one of the possibility, that is the distance is 15. So in the another way to reach the vertex 3 from 1 is, so I can reach 1 to 2 as well as from 2 to 3 I can able to reach my destination, right? So here the total distance from 1 to 3 is 1 to 2 is 4 and 2 to 3 is 2. So total distance is 6. So here I'm having two paths to reach from my source to the destination. One is it reaches with distance 15 and another one is it reaches with the distance 6. So the minimum distance is 6. So I need to identify all the possibilities of distances from one vertex to another vertex. At final I can identify the minimum distance from each and every pair of vertices. This is the main objective of our all pair shortest path as well as Flood's algorithm, right? So here I'm going to use the strategy called dynamic programming to solve all the pair shortest path algorithm, right? So the dynamic programming is an optimization problem. So optimization problem is nothing but the problem which contains the results as the maximum or minimum. So those problems are said to be optimization problems. In dynamic programming, we will try to find out all the possible solutions. Then we can choose the best or pick up the best or optimal solution among all the solutions that I have been explained previously. So because of finding all the possible conditions, the time complexity for dynamic programming is high when compared with other strategies. So in dynamic programming, which follows principle of optimality, that says that the problem can be solved by taking the sequence of decisions to get the optimal solution. In this all pair shortest path, the shortest path between the nodes can be calculated by using the formula, that is aij whole power k is equals to minimum of, it is a minimization problem, so that we are using minimization, that is minimum of a I j whole to the power of k minus 1 comma a I k whole to the power of k minus 1 plus a k j whole to the power of k minus 1. So it is the formula which I am going to apply later on. So initially a naught is the matrix that can be built as the weights of I comma j, that is the initial weights of each and initial weights between the pairs of vertices, right? So for example, here it is a given graph that contains 3 vertices. So I need to build A naught as 3 cross 3 matrix. So based on the number of vertices, the matrix can be built. So if the given graph contains 4 vertices, in the sense I need to build 4 cross 4 matrix. So and then if number of vertices will be 3, so I need to identify 3 matrices, that is A1, A2, A3. In A3 only I am getting all the possibilities of minimum distances between the pair of vertices or nodes. Right. So how I'm going to fill the matrix as the A naught can be initially A naught can be filled based on the weights given in the graph. Right. So initially, so 1 to 1. So 1 to 1 is 0 because the distance from one vertex to the same vertex should be considered as 0. Therefore, all the diagonal elements becomes 0. So because the distance from 1 to 1 is 0, the distance from 2 to 2 is 0, distance from 3 to 3 is 0. Then next 1 to 2. So 1 to 2 is 1 to 2 in this direction. I am having the distance as 4. So I need to place 4 here. So 1, 2, 3. So the distance is 15. So I need to place 15 here. Then next 2 to 1. So 2 to 1 I am having distance as 8. So I need to place 8 here. So 2 to 2 is 0 because it's the same. So 2 to 3, so to 2 to 3 I'm having the distance as 2, so I need to fill 2. So 3 to 1, that is I'm having a distance as 3, so I need to place 3 here. So but I'm not having any path from 3 to 2, so I can place infinity. I can assume that it's an infinity, that is I don't know the distance. If there is no path between the nodes, we can assume that as infinity. So and then next 3 to 3 is 0 because it's a same. So the distance from 3 to 3 is 0. So is it clear? The next, here I need to identify A1, A2, A3. So A1, A2, A3. A1, A2 and A3 because I'm having 3 rows as well as 3 columns because of I'm having the 3 vertices in a given graph. So that I need to identify A1, A2, A3. A1 can be calculated based on A0, A2 can be calculated based on A1, so A3 can be calculated based on A2. Alright. So here I am having, yes, so here I am going to calculate A1, right? So A1 based on A0. So here, so when I am going to calculate A1, I need to keep first row and first column as it is. So here the first row as well as the first column as it is, which is present in A1. So and all the diagonal elements should be 0. So that in such a way I need to identify 2 elements, that is A1 of 2 comma 3 as well as A1 of 3 comma 2, right, based on A0. So I'm having the formula that Aij whole to the power of k is equals to minimum of Aij whole to the power of k minus 1 comma Aik whole to the power of k minus 1 plus Akj whole to the power of k minus 1. So based on that, here k value is equals to 1 and I is equals to 2 and j is equals to 3. So here a k minus 1. So k minus 1 is 1 minus 1 becomes 0. I comma j is 2 comma 3. So comma a 0. Here I comma k. So 2 comma 1 and here a k comma j. So that is 1 comma 3. So here Right, so the minimum of a naught 2 comma 3, so a naught 2 comma 3, that is 2, and a naught 2 comma 1, so 2 comma 1 is 8, a naught 1 comma 3, a naught 1 comma 3, so that is 15. So here, so 2, 8 plus 15 is 23, so the minimum of these two values is 2, so therefore a 2 comma 3 of 1, that is 2. So then next I need to identify the value of a 3 comma 2 whole to the power of 1, so that is equals to minimum of a naught 3 comma 2 I comma j and a naught 3 comma 1, so that is I comma k, and plus a naught 1 comma 2, so that is k comma j. So therefore minimum of a naught of 3 comma 2, so a naught of 3 comma 2 is infinity, so here I place the infinity. Then next a naught of 3 comma 1, so a naught of 3 comma 1, that is 3, and then a naught of 1 comma 2, so a naught of 1 comma 2, that is 4. So here I placed 4. So therefore infinity comma 3 plus 7, 4 is 7. So based on these two values the minimum element is 7. So therefore a1 of 3 comma 2 is 7. So I need to replace here as 2 and here it is 7. So see it here. So therefore a1 becomes 0 4 15 802 370. Right, I have been replaced these two values in a1. So while finding a2, keep the second row and second column as it is. So here the second row is 802 and the second column is 407. So I am going to keep these two values as it is, and the diagonal element should be always 0. So I need to find this value and this value. So while finding, what is this, a2 of 1 comma 3, a2 of 1 comma 3, and then a2 of 3 comma 1. So I need to identify these two values. So a2 of 1 comma 3 is equals to minimum of a1 of 3 1 comma 3 comma a1 of 1 comma 2 plus a1 of 2 comma 3. So here the a1 of 1 comma 3, so a1 of 1 comma 3 1 comma 3, that is 15. So 15, a1 of 1 comma 2, so a1 of 1 comma 2 is 4, so 4. So a1 of 2 comma 3, so a1 of 2 comma 3 is 2, so here 2. So therefore 15, 4 plus 2 is 6, so the minimum value among these two values is 6. So a2 of 1 comma 3 value is 6. So therefore I am going to find a2 of 3 comma 1. So therefore minimum value of a1, that is k minus 1. So k value is 2, so it becomes 1. So 2 minus 1, that is 1. So I comma j, so I comma j is 3 comma 1. So a1 of I comma k, so that is 3 comma 2 plus k comma j, so a1 of 2 comma 1. So a1 of 3 comma 1, so a1 of 3 comma 1 is 3, so here 3. So a1 of 3 comma 2, so a1 of 3 comma 2, that is 7. Right, so a1 of 2 comma 1, so a1 of 2 comma 1, that is 8. So therefore 3, 7 plus 5 is 15. So here the minimum value is 3. So a 3 comma 1 to the power 2 is equals to 3. So I need to replace these two values in here. So one is 6 here and 3 here. So the matrix becomes, so add a2 becomes 0 4 6 8 0 2 and 3 7 0. Right. So while finding a3, keep the third row and third column as it is. So here the third row this row and this column as it is. So by keeping those things as it is, my matrix is A3 becomes 0. All the diagonal elements should be 0. I need to identify these two values. All three values are remaining same. So here I need to identify A3 of 1 comma 2, A3 of 1 comma 2, and then A3 of 2 comma 1. Right. So A3 of 1 comma 2 is nothing but minimum of A2 of 1 comma 2, that is I comma j, comma A2 of 1 comma 3, that is I comma k, and plus A2 of 3 comma 2, so that is k comma j. So therefore minimum value of A2 of 1 comma 2, A2 of 1 comma 2, so 1 comma 2 is 4, so here 4. So A2 of 1 comma 3, so 1 comma 3 is 6, so 6 plus A2 of 3 comma 2, so A2 of 3 comma 2, that is 7. So here 4, 6 plus 7 is 13, so minimum of these two values is 4. So A3 of 1 comma 2 is equals to 4. Alright, so then I need to identify A3 of 2 comma 1. So that is the minimum of A2 of 2 comma 1 comma A2 of 2 comma 3. So plus A2 of 3 comma 1. So therefore A2 of 2 comma 1. So A2 of 2 comma 1, that is 8. So here 8. A2 of 2 comma 3. So A2 of 2 comma 3, that is 2. Then 2 plus A2 of 3 comma 1. So A2 of 3 comma 1 is 3. So here it is 3. So therefore 8, 2 plus 3 is 5. So minimum of these two values is 5. So A3 of 2 comma 1 becomes 5. So I need to replace these two values here. So here it is 4 and here it is 5. So the matrix becomes A3 becomes 0, 4, 6, 5, 0, 2, 3, 7, 0. Right? This is the final matrix which contains all the minimum distances from each and every pair of vertices or nodes. Right? So thank you.